Hi there, welcome back to the channel, and welcome to a new video. This video is specifically on the SABA FM stereo decoder, this guy over here. These decoders were used on a lot of the SABA radios that came out when the stereo was becoming a thing, FM stereo of course. I'd always looked at this as a little bit of a mystery. I'd never opened one up. I'm very reluctant to open up aluminium cans that look like they should stay closed. This is another one of them, and the FM front end is another one of them. What I've learned in the past and what this video is going to show is that once you open it up, the mystery's gone. The fear is gone. It actually isn't as difficult, as complex as one might think. I was a little bit worried about messing it up. I nearly messed it up, but I didn't. And the result is that I learned a hell of a lot from this. And this is why I decided to do this video outside of the series on the restoration of this SABA Stereo 1 that I'm working on. This is specifically on the decoder, and I think that's important because you can find this decoder on a lot of the SABA radios. In fact, the workings of these decoders on other brands like Grundig, Telefunken, I'm not 100% sure, but I'm almost certain that the workings are pretty much the same. Not that you can just plug them in alternatively, but if you know how this works and you know how to adjust it and align it and fiddle with it, you will definitely gain a better understanding on how these things work. And the mystery goes, and then another field opens up to you. So once the fear is gone, you can tackle anything. In this video, I'm going to look at the scope. I'm going to look at what happens at each stage of this decoder, what it looks like on the oscilloscope, how we can adjust it. And by the end of the video, you'll see that it's actually quite easy to make the alignments and the adjustments, and the result is well worth it. Hope you enjoyed the video. Our famous stereo decoder. Now, I mentioned last time that I was a bit disappointed, and somebody, actually more than one person mentioned this, but one of you actually sent me the service instructions for this particular decoder, which means I can now go and prod around in it, which perhaps I shouldn't. But I can't resist. I've got to see how this thing is set up. There are a few electrolytic capacitors in there which probably do need changing. So I'm going to see if we can do something about this, if it needs any adjustment. There's a full service manual on this, various models. This is the E16. Okay, that's good to know. How do we get this thing out? Okay, there are these clips over here. I think it's as simple as doing that. And does this just come out? Yes! Brilliant! Will you look at that? Our decoder. And it does have quite a few electrolytics. There's 1, 2, 3, 4, 5, 6. Now I'm not sure what condition they're in. I'm not sure what condition the other components are in. There are a lot of diodes on here, a few transistors. 1, 2, 3, 4, 5. These, I believe, are all germanium. And a few inductors, tunable inductors. A couple of pots over there, trim pots. So I think what I'm going to do is I'm going to take out the schematic. I'm going to check some of these components. I may just go ahead and... now let me be straight. This thing was working. I'm not sure how good the stereo pickup was working. When I tried it with my little stereo signal generator, it was lighting the stereo lamp. So it is picking up stereo, but if I can just fix up some of the problems, I may be able to improve that. And quite honestly, this is for my curiosity more than anything else, which is normally not a good reason to mess around with these things, but I can't resist. I can't resist. I can regret, but I can't resist. All right, let me have a closer look at this and I'll get back to you. I had no idea this thing actually just popped out. It's got these pins at the bottom, and you just pull it out. No big deal. Obviously connects to that. That's one of the first things I'm going to clean. That would make sense. And I can get access to all the components. A few cobwebs over here. But I can get access to all the components, and the one thing that leaves me a little bit optimistic that I might be able to actually improve this is the fact that it's got a lot of these little resistors here that have been plaguing me. These have been notoriously off, but everything is very easily accessible. And what will I need to access? It's going to be a few capacitors, resistors there. Those are polystyrene. That one. There's not much in here. And I don't want to do too much to this because remember, this thing is a little bit like that front end box of the FM. If you can avoid it, avoid it. I'm doing this at my own risk for my own curiosity, which, as you probably know, killed a cat. My cat's not listening. But anyway, let me get cracking and see if I find anything glaringly off here. If anything, it'll be probably the resistors. As I said, this thing's working, so I don't expect anything too dramatic. But it should be fun. Let me work on it for a while. So here's the symmetry of components. All the electrolytics and all those really crappy resistors have been swapped out. Some of the resistors were pretty far out. None of them were completely open or completely shorted or anything like that. I tested the SRs and some of these capacitors. They were on the highish side. They weren't completely unusable, non-functional, but I've changed them anyway. So let's have a look at the result. It's done. These, what do you call them? Clamps, whatever it is. They've been cleaned. The contacts on this side have been cleaned. This thing has gone a strange color from the alcohol that I used, the isopropyl that I used to clean it. Other than that, as you can see, everything is pretty neat. Everything fits well. All the capacitors are new. The resistors, I've used 600 milliwatt resistors. They actually ask for, most of them were 1/10 of a watt. I didn't even know you got them. But most of them were 1/10 of a watt. Now this will just go in here. If I can get it in there. Push it all the way down. And then the casing will just fit in here. There's actually a groove that you can see there where the PC board goes in. But I'm not going to put it in yet. I just want to see that it does go in. There we go. And then that clamp over the top will hold it in place. So this is good. This is good. And what it allows me to do, because I've got access to all the points down there from 1 to, 8, I think it is. I think I'll be able to actually test this. I'm not sure just what the effect will be of having this unshielded. It will have an effect, but it might be good enough for us to test. Anyway, that's good. That was quite easy, very easy. And due to the number of those resistors that are in there, I think it's really worth replacing them and the capacitors. Now, the capacitors and the resistors don't really function in the tuning stage. I think the tuning is primarily, the alignment is primarily with the cores and maybe the trimmers over there. They do tell us that if you don't replace any of the tunable components, you shouldn't necessarily have to make any adjustments. But I'll go and look at the instructions and see what it is we can sniff out of here and perhaps see what the signals are and look for the pilot tone and double the pilot tone. This thing comes in with 19 kilohertz pilot tone, which is when a stereo signal is transmitted. And this thing actually doubles it to 38 kilohertz. And that's where you create the left minus right, which then adds to left plus right and gives you 2 times right and 2 times left. Yeah, I think you know how that works. If you don't, just look it up. And this thing works, it uses the switching system, which is also described in that service manual. You've got various ways of getting the decoding done. They use the switching, alternate switching. So it'll be interesting to just probe around here. I'm going to try not to change much because I don't want to end up messing it up. But I do want to see what's happening inside there. Good. And this is our schematic and indication of everything that I've changed. As you can see, there's not that much there. But these are the ones those resistors that I thought needed changing, and testing them proved that that was the case. So these guys here are supposed to be 0.1 watt resistors, okay? I replaced them with 600 milliwatts, so that's not a problem. The other resistors they have here are 1/4 watt, but I don't think I replaced any of them that are 1/4 watt, and even if I had, that wouldn't be a problem. The capacitors I've replaced with 4.7 microfarads. I don't think they affect the tuning of this at all. If you look at the tuning, when they say that you shouldn't need to adjust anything if you don't play with the tuning components, what they probably mean is the tank circuit. So this coil, this capacitor, that's a tank circuit. If you replace that capacitor, you need to adjust the coil. Maybe even things like that, but certainly not these. What else would you need to change? Well, if you play with that and you change that around, you'd probably need to tune that one. In this case here, you've got, well, over here, you've got that capacitor there, that capacitor there. That's obviously part of the tuning circuit. But anyway, I don't think I need to fiddle much, but I do want to. And let's have a look at what we have here. They describe this whole thing quite neatly, quite completely in the service manual. This is the E16 that we're working on here. So it's the exact service manual that we need. They describe the multiplexing to tell you how you arrive at the 2L, 2 times L, 2 times right. So that's your left signal and your right signal. It actually gives you double the levels that you would normally have as a result of all the summing and subtraction that the diode networks do. Just read through that. It's quite simple. The primary aspect here that determines whether you've got a stereo signal or not is whether the signal's got a pilot carrier, 19 kilohertz pilot carrier. That is what separates a non-stereo signal from a stereo signal. Now, we'll see that on the scope. This is what I want to do. I want to show you what happens, what it looks like on a scope. It goes through the whole thing, and here's some more telling you what the switching works, how the switching works. But the important thing is this thing over here. It tells you how the schematic works. And it's actually quite neat. If you look at this and we start looking at one step at a time, it's actually very interesting how this thing works. What happens is the signal, the composite signal that comes out of your ratio detector, in other words, that guy over there, that's your signal, I. And if you follow this line up here, over there, and you go to the right, you see that I comes into 1. It's actually a Roman numeral 1, it's not I. So that's where it comes in, and you find that the other connectors over here, let's see what they do. That one there is one signal out to 8, so 8 and 6, 8 and 6. If you follow those to the left over here, you've got them here, 8 and 6, and you can see that that's your inputs to the stereo selection thing over here, which is where we join the external inputs as well. So those are your outputs, your left signal, right signal outputs. That one there is ground, 7 is ground. That trimmer there is what you use to set your indicator on your magic eye. 2 is, what is 2? What is 2 and 4? There's no 3. 2 and 4 are the same. What are these guys? Maybe if we look at the schematic of the actual decoder, we'll figure it out. Let's have a look. 2 is the output from, that's a DC voltage output. I believe 2 is the one that goes to your magic eye. Is that right? 2, that goes to magic eye. Yes, 2. And 5 is actually a supply voltage of 18 volts over here. 5 over here, I don't see how this thing can be 18 volts. Oh, it is. It's from a supply over here. There's B over here. Okay, B is a low voltage supply, so 18 volts. So that's your supply, and the actual indicator is 2. And that would be setting the level for stereo indication. Okay, so what do we have coming in here? We've got the composite signal comes in here, and that composite signal will be, let's call it an audio tone of 1 kilohertz. And let's say it is stereo. So it comes in here and it meets, well, it'll actually come in here and out there as well. So it'll come in here and it'll meet this, this transistor, and it'll get amplified. So we should see that 1 kilohertz coming out here. And if it comes out here, it goes through that capacitor, through that filter. That filter is to remove high frequencies. Actually, it's to remove harmonics of the 19 kilohertz. They tell us to tune it to 4, was it the 4th harmonic or 3rd harmonic? We'll see it in a minute. So that audio is coming in here and it's going to there, to this point here. And then it gets distributed up and down. And the amount of up and down, in other words, the separation that you give it, that it gets, will depend on the level of the spot. And then this one will amplify, that one will amplify, and that then gives you your left and your right signal coming out. Okay, so this is sort of the audio path. What goes through there depends on this stage here, these diodes. This is what does that switching separation of left and right channel. And the way this works is by using the 19 kilohertz that comes in here. It gets picked up here, gets amplified here. This is all described. I'm not being clever. This is all described in that circuit description. Gets picked up here, and then it drives. It's doubled with this circuit over here. This gives you 19 kilohertz coming out, going into this coil, and the output over here is 38 kilohertz, so double. It also gives you a DC voltage over here, which is an indication of the fact that you've got stereo. But that signal, that 19 kilohertz, comes through this stage, this capacitor, through there to this transistor. It in turn amplifies it, and it goes through this coil. And at this point, you should have 38 kilohertz at about 17 volts peak to peak. I believe that's what VSS means. About 17 volts peak to peak. We're also going to be able to see that on the board, and then that will create the stereo separation, the switching separation to give you left and right over here. So let's have a look at this scope and see what it is that we're actually getting. All right, let's have a look. What have I done here? I was playing around. I wanted to really probe this board. This one, it's in circuit, it's working, but I wanted to probe it, so I decided to remove it from there. I didn't want to work too closely to high voltages, and I soldered these little wires with those clips that are just going over there. It seems that the fact that this thing's outside the board is outside there without a shield is not doing much to affect its performance. So that is now connected. I've got the scope actually connected to the composite signal input. In other words, to the input going into this decoder. And what I've got here is I've got 90 kilohertz, okay? And I've got it on lowest RF power with attenuation. There's another attenuator up there. And the modulation I'm using is mono. Now, what are we seeing when we see this? Let's have a look. See that? What we're seeing there is a 1 kilohertz tone. Now, if I had sent a 100 hertz tone or 10 kilohertz tone, that's what we'd see. There's a 1 kilohertz tone, there's a 100 hertz tone, okay? We'll leave it there. And what I'm going to do is I'm going to the audio, I'm going to the modulation type, and instead of mono, I'm going to hit stereo. Now watch this. See that? You know what that is? If I freeze the scope, what you're seeing there is a 1 kilohertz tone with a 19 kilohertz superimposed on it. Now, if I had a spectrum analyzer, we'd see that very clearly in the frequency domain. What we're seeing here in the time domain is not as clear, but it's pretty obvious. It's 19 kilohertz that is superimposed on that audio. Get the scope running again. Modulation. If I put mono, we're back to just the tone without the 19 kilohertz. If I do left only, so that's my my signal's coming in only with the left signal on. That's what it looks like. With the right, that's what it looks like. Muted, it's gone. But there we go. That is our 1 kilohertz tone in stereo. And we can clearly see that the carrier is superimposed on that, okay? Now, what else do I want to see? If we look at the schematic, it tells us that there's a point where you should have 38 kilohertz. And 38 kilohertz, if I'm not mistaken, is here. Yeah. And it tells us 17 volts peak to peak. Now, I'm going to drop that scope down. And look at that. Let's get the measure function on here. That is 14 volts peak to peak, and it's 38 kilohertz. Near as damn it. And that's a very nice wave. That's a very nice signal. That is the signal, a frequency on the scope. It's telling us 38, 37.9, 38, 38, 37.9. Okay, that's fine. And it's 14.32 kilohertz peak to peak. Now they tell us 17 over there, which is fine, okay. And what else can we probe on here? Let me think about this. We can also probe pin 2, and pin 2 would be that indicator, stereo indicator. Let's see what we can find. And if I probe pin 2 DC meters, I'm doing it at the board 1.4. That doesn't seem right. Isn't it supposed to be 18? No, 5 is supposed to be 18, so I can go here and check for 5. Let's see. What is that? 1, 2, 3, 4, 5. No, that'll be going to the, yeah, that'll be going to the indicator. There we go, that's 5. That'll be the supply, and I've got dim bulb on there, so it's probably why it's not 18. That's our input supply, and that one there is the indication that goes to the magic eye, stereo indication. Okay. So this is pretty cool. You can actually play around with it. There's no high voltages here. The highest supply voltage here is 18 volts. I've cleaned this. I managed to get rid of that dull look that this thing had. Don't know why. It's probably the alcohol that had some residue or something, but it's looking pretty neat. And it's working very, very well. Now, what I can do is I can check the outputs and see what the separation is like. Let's have a look at that. That'll be interesting as well. What have we done? We've checked this point over here, and we can see that strange looking sine wave with the 19 kilohertz superimposed on it. That goes in here, that gets amplified, it gets to there. Now they tell us that this guy is to filter out 114 kilohertz, which is 6 times the 19 kilohertz. So this is supposed to null it out, and we can do that with coil 1. We'll probably do that at the end if we need to. I don't think we need to, but that would then come over here. But what happens when we have stereo? So the 19 kilohertz has obviously been picked up here. I haven't looked at the 19 kilohertz by itself, but I have found that the 38 is here, and it's pretty strong. It's a very strong signal, so it is going to drive these diodes to do what they're supposed to do, which is the switching. And then, so the left and right will go to the respective outputs over here, output amplifier over here, and then down to the outputs over here, which are 6 and 8. Those are the left and right signal over there. We have to think about, oh yes, what I want to do is I want to send a signal in here, and I'm going to just make it left or right and see what comes out of this side and that side. In other words, how much of the left signal comes out on the right and how much of the right comes out on the left. Because I know you can adjust it somewhere. I think you can adjust it. I think it's either that guy. It's either that guy or that guy that you adjusted. But when I do the adjustments, I want to know why I'm doing them, which is why I want to look at this thing and see how it behaves. So let me set that up. Okay, what I've got now is I've got the probes, the 2 oscilloscope probes at the output, left and right output over there. And we can just see them one on top of each other. Not very visible, but if I do that, you'll see they're actually on top of each other. Let me move this down. Nah, I'll leave it there. Let's do that. They are literally on top of each other. I think one is slightly bigger than the other one, okay? Now that is because I'm sending audio modulation stereo. Now, if I hit mono, it goes up. Not sure it should, but it does. I'll have to think of that logic there somewhere. Maybe with the alignment, it will change that. But if I hit left, watch this. Now that's because it's triggering on the yellow, and the yellow is too low. Let's do that again. Okay. Our left channel is yellow. Our right channel is purple. Now if I go to right, it's reversed, okay? So that is effectively giving us an indication of the stereo separation this thing is allowing. Because if it was absolute, you'd get that purple trace completely at 0. But it's not. So there is some adjustment here for stereo separation. I'm not quite sure which one it is, but I'll find out. And it's got to do with these trim pots, I'm sure. I can't remember now, but I'll look it up. And if we go back to stereo, there we have our stereo signal. Pretty cool. Left, right. Ha! I like it. I like it. Okay. All right. Let me stop tampering with this before I mess it up. I'm going to remove the solder connections on there, put this back on there. If I want to make any alignments, any adjustments, I'm going to have to do that without, with this cover on, because I'm sure it'll make a difference. I'm not sure that I should mess with this, but hey, I've gone far enough, haven't I? Let's see what we can do next. Since I've got this thing hanging loose here, I'm going to do some of the alignments out here. The first one I'm going to do is that the trap, that low pass filter on coil 1, L1 up here. Here it is. To align the decoder completely, connect an 18 volt supply. And that's what I've done here. I've got 18 volts coming from the power supply, and it's connected across that first filter cap. And that is between ground and the supply line. 18 volts, it's drawing less than 10 milliamps. So this is working correctly. Then they tell us to connect a input to the input line, to the first, to number 1 over there. And what I've got coming in there is 114 kilohertz. And it's at 150 millivolts RMS. And now I need to align this coil here till I get the lowest result, the lowest amplitude on the scope. Now, let's see what I have there at the moment. Now that's 114 kilohertz. Now let's see what happens when I turn this a little bit. What you're doing is you are filtering out with a low pass filter some of the harmonics. Don't see much, do I? Let's see if I put it at 19 kilohertz. It's there. If I go to 38 kilohertz, still there. 76, I'm just going up in harmonics, doubling. Still there. See what happens when we go up. You see there's a dip over there. Between 116, 106. Let me go up in units. I'm going to start at 110 kilohertz, go up in steps of 1 kilohertz. So 111, 112, 13, 14, 15, 16, 17, 18. Okay, you see that? It is trapping at 114. There's the minimum, 114 kilohertz. So that's fine. I don't need to do anything else there. The remainder of the tests, I'll probably prefer to do them in the radio because it's got to do with the stereo separation. And I'm going to use the radio's detector to provide the signal that I want there on left and right, and then reduce the actual crosstalk. Okay, let me put that back. Right, well, they tell us now what to do next. Essentially, they tell us to connect a stereo signal. I'm doing it in there. I'm not doing it outside of the radio, because I'm feeding the signal that they tell us to feed. I'm feeding it with this little signal generator here. And what I'm sending is a stereo signal, 1 kilohertz tone. And if we look at the scope, we can see that I'm getting it on both sides. One side is slightly higher than the other. We can see that if I emphasize the yellow channel. But we are getting our stereo signal coming through. So these are the two outputs from the decoder. And if I go to this guy here and I make it mono, it goes up and you see no 19 kilohertz signal on there. I'm not sure that should be there at all, but if we do left, right, you can see that they alternate between the two. And I'm sure there's a lot of crosstalk, which is one of the things we need to sort out over here. So let's put it back to stereo. And they tell us also to connect a multimeter to the output 4. Now, output 4 is that signal that goes to the indicator of the stereo on the Magic Eye. So the first thing they tell us to do is to adjust L2, L3, and L5 for a maximum on the VTVM, which is there. So I'm going to see if it makes any difference. I'm going to do this very carefully. I don't want to overdo it. Well, that's going down. That's pretty much peaked. That was peaked over there. This one. We're getting a bit more out of this one. That's about a peak over there, and this one. No change. I think the difference there has decreased on the scope. That's good. Okay. So basically that's what we've done. Now they tell us to adjust, and I'm really not going to do much else. I'm going to adjust P2, I think it is, for the maximum crosstalk attenuation. I'm not sure what P1 is. Hey, let's fiddle. Let's see what happens. P1 is that guy over there. Let's see what happens when I adjust P1. Try not to touch anything and not get zapped. That would not be good. Ah. That brings the two closer together. Okay. But is this the most I can do, the best I can do? That is about as good as it's going to get. I might do a little bit more adjustment later. Now the crosstalk, I need to set this to mono. So I'm going to go down to the audio here, modulation. I'm going to give it just left. And now I'm going to adjust P2 for the best crosstalk attenuation. In other words, how small can I make that yellow trace? Again, careful I don't get zapped. I think I better do it the other way because I'm going to put the modulation on the other channel because my scope is triggering on the yellow. So now I need to make the purple as small as possible. I think that's about as good as it gets. Not much more. I'm going to do this all again without the camera going because it is very difficult. And then they tell us to L3 for the maximum crosstalk attenuation. L3 for the maximum crosstalk attenuation. So that's this guy over here. I need to see if I can improve that. There we go. That's the best. That's as good as it's going to get. And of course, one of the things I need to adjust is this little trimmer here, where I'm going to tune it to I'm going to make the signal stereo as low as possible. And then I'm going to adjust that till the magic eye just closes to indicate stereo. And then we're good. You know what? That's about as much as I think I can do without creating havoc here. This thing's already looking a little bit precarious, but it's all in. It's working perfectly. And I'm actually surprised that it's been done. I've had this thing playing for some time now, and the reception, the actual separation, the stereo effect is very, very good. A lot better than I expected from this device. Perhaps I'm just being a little bit unfair to the generation that it comes from, but then so do I. But it's working very, very well. And what surprises me is actually how simple this is. You know, you look at a box like this, it's covered in an aluminium shield, a little bit like the front end over there, and it can be a little bit daunting. I know how it was to me. So perhaps after this video, you'll be a little bit braver and less fearful of opening one of those things up. And the other thing is, I think that once you get this thing working well, it can work on any of the other SABAs unless the connections are different. You just have to check the schematics. If they're all the same, I'm sure it'll work exactly the same on a lot of these models. So I'm pretty pleased with myself. You can probably hear that. And I hope that you are pleased that you stuck around, if you have stuck around this long. And I hope you've enjoyed the video. So if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon, PayPal, links in the description below. Thanks for watching. Bye for now, and stay safe.